Newton's first law states that an object in motion tends to stay in motion unless it is acted upon by an opposing force. This is considered the law of inertia. An example of this would be in a baseball game. The batter is set and ready to swing. The forces acting upon the bat are balanced. When the batter decides to swing, he adds a force into the equation, thus moving the bat forward. When the batter adds a third force into the equation, the bat moves forward because it is no longer balanced. After the batter swings and the ball is hit, inertia comes into play even more. Once the ball is hit, its inertia keeps it moving. If the ball is hit at the ground, the ball will continue to go to the ground and even skip off of the ground. This is because the Earth has a larger inertia than the ball, so the Earth moves negligible amounts, but the ball bounces high off of the Earth. The second law by Newton is the law of force. Force is calculated using the equation F equals ma. This equation dictates basically everything that happens in the world, but a baseball-related example of this is a batter running towards first base. Because you can run through first base, the acceleration to the base is constant. The batter's mass in this equation is 90 kilograms, his acceleration being 4.1285 meters per second squared. His final force is 371.57 newtons. The game of baseball, just as any other sport, is entirely based off of forces, so examples are everywhere. Another example is a pop fly. A baseball has a mass of 145 grams, or 0.145 kilograms. The acceleration due to gravity is 9.81 meters per second squared, so the ball has a total force of 1.42 newtons. Calculating forces plays a large role in both player safety and the excitement of the game. It lets coaches make better adjustments, it makes bat companies make safer bats, and allows officials to make better rules. All of these contribute to making baseball a higher form of entertainment. Isaac Newton's third law states that for every action there is an equal and opposite reaction. These reactions happen every second of every day, but have a huge impact on things like sports. One example of this is a player in the field. When the ball is hit or thrown towards the player attempts to catch the ball with his mitt. When the ball hits the mitt moves backwards, but also slows the ball. The force the ball applies on the mitt is equal to the force that the mitt applies on the ball, so the mitt moves backwards, but the ball also slows down. The force the ball applies on the mitt is equal to the force that the mitt applies on the ball, so the mitt moves backwards, but the ball also slows down. Another example of equal and opposite reaction, this time a little more thrilling, is a home plate collision. The batter is running down the baseline, and the catcher is standing still guarding the plate. When they run into each other, the batter is slowed down and the catcher is moved backwards.